For our lesson preview, choose one of the following problems. Use integration to determine the volume of a sphere, or use integration to determine the volume of a pyramid. Take the time to put some effort into these problems. Afterwards, we'll discuss the volume of a donut. Begin by drawing the picture. In this case, a sphere is a circle that is spinning about the x-axis or the y-axis. I choose a spin on the x-axis, so we have a spin x. With that in mind, we need some sort of equation to go with it. This is a circle as it's being spun around, and we know that for a circle, x squared plus y squared must be equal to the radius squared. So draw the picture first, know where you're spinning, then begin with the shape. From that point on, you should be able to use spin x, use x in order to find the volume of the problem. Once you find the volume of the problem, you're going to integrate. This integration comes out to be very nice and will include the constant r within your integration. If you tried question B, first draw the picture. Figure out where your endpoints are. We have 0, 0, 0, h written in. And as you think about what a pyramid looks like, it is lots of squares that are being stacked on top of each other. And these squares, we can use cross-sectional volume in order to determine the volume of your pyramid. What we recognize from our picture is that there are similar triangles occurring. So if we're cutting on our y-axis and we think about these similar triangles, we would then see that the area with respect to y of each one of those squares divided by the base of the entire problem, or divided by the base of the entire pyramid, is going to be equal to our y squared over the h squared using similar triangles. From here, you could then write that the area with respect to y is going to be equal to b times your y squared over h squared. Now, you have the area, and you know that the volume is going to be equal to the integral of your y values from your 0 to h in this particular problem, by squared over h squared dy. And then you will integrate. For today's lesson, we are going to find the volume of a torus. What is a torus? It is actually a donut. In this particular problem, we are going to take a circle, draw your picture. Our circle has a radius of a. We're going to center it at the origin. That'll make it easier to write our equation. So the radius is going to be a, so we have a0 as one of our points. Centered at the origin, we know that x squared plus y squared is going to be equal to a squared for the equation of your circle. We're going to take your circle and we're going to spin it about the axis. In this case, we have x equals b. Now, and with x equals b, you know that you're parallel to the y-axis, so we're going to spin y and then decide if we're going to use y values or x values in our equation. So if we were to use y values, let's see what would happen. Using a y value, we would need to have an outer radius and an inner radius, but as we think about big R squared minus little r squared, the shape of the circle is going to make that challenging for the subtraction, and we're not going to be able to get the figures that we were expecting. So spin y, use y is not working for us. Well, the next idea that we want to use is spin y, use x. Let's give that one a try. If I were to use my x values, the radius coming off of where we're spinning goes to some arbitrary point within our region. So that could work. We can figure out that value. And the height is going to be perpendicular to that radius. So I think we've found our method. Spin y, use x. And the area formula that we're going to use within our integral is 2 pi r h. Now we need to figure out the radius. So the radius with respect to x is going to be the right endpoint minus the left endpoint. So again, the left endpoint is going to be given to us from the arbitrary value xy that we're using. So the radius is going to be b minus x. The height, which is perpendicular, is going to be equal to, with respect to x, top minus bottom. Now the top of the curve is the positive square root of a squared minus x squared. Now remember, the top is positive. The bottom of the curve is the negative square root of a squared minus x squared. So when we put those together, we get 2 square root a squared minus x squared is your height. So the volume of the picture is going to be created by volume equals 2 pi. We'll get the endpoints in a moment, and then we'll have the radius, which is b minus x, times the square root of our 2a squared, whoops, slipped the 2 in the wrong spot, 2a squared minus x squared dx. Now, what are the endpoints? The endpoints are your x values, and because of the circle we've drawn, we know we're going to be integrating from negative a to a. But let's exploit some symmetries and go from 0 to a. Oh wait, we can't do that, because when you spin this axis around, the shape on the right is not the same shape on the left. So we cannot exploit symmetries. We have to go from negative a to a in order to find this problem. All right, so here's our volume. Now this volume is a bit tricky to integrate. So let's factor out our 2, which gives us our 4 pi. Then we're going to have the integral from negative a to a. Let's distribute. And if we distribute, we're going to have b times the square root of a squared minus x squared dx minus the integral. Now we're going to go from negative a to a of our x times the square root of a squared minus x squared dx. Double check my algebra, make certain everything's working out well. Okay, so we're actually going to look at the right-hand side of this problem first. Let's keep our 4 pi, the integral from negative a to a, b times the square root of a squared minus x squared dx, and focus on what's happening on this right-hand side. In order to integrate this part of the problem, we're going to let u equal a squared minus x squared. So your du is negative 2x dx. When we substitute, dx is going to be du over negative 2x. And what we now have is the integral. I'll deal with my endpoints in just a moment. So we'll have x square root of u. Dx is replaced with du over negative 2x. Now, as you can see, the x's will cancel. Isn't that convenient? All right, now let's deal with our endpoints. If we let x equal negative a, we know that u is equal to a squared minus x squared. So substitute in. We're going to get u is equal to a squared minus a squared, and that is 0. So the bottom endpoint is 0. Now, if we let x equal a, let's see what happens. U is equal to a squared minus a squared, which is also 0. So we're integrating from 0 to 0, and the right-hand side of our expression becomes 0. Now we get to deal with the left-hand side of our expression. So as you look at this, we simplify a little bit. We have 4 pi integral from negative a to a, b square root of a squared minus x squared dx. What I'd like you to see is that this is a geometric integration from your AB course. That is the equation of a semicircle. An integral is asking for area. So what is the area of a semicircle? The area of the semicircle is going to be equal to 1/2 pi and then the radius squared. Well, as we look at this problem, the radius is a, so the area of our semicircle is 1/2 pi r squared, which is replaced with an a. So since integration is representing an area, this is 4 pi times b times 1/2 pi a squared. Simplify, and we have 2a squared b pi. So that tells us that the volume of a torus is equal to 2a squared b pi. Now there was a lot of important math that just occurred in this one little problem. First, we determined whether or not we should use our shell method or if we should use our disk washer method. Afterwards, we had to use algebra to set up our problem, use substitution to solve the second part of the problem. Then we went back to our AB ideas, and you're asked to remember that if you're finding the square root, if you have the integral of a square root of a semicircle, you need to exploit your geometric principles in order to find that integral. So this question has a lot going on. Make certain you understand all the key components. Once again, you are to determine the length of a segment for y equals 3/2 x to the 2/3 from 0 to 8. Now we haven't talked about a formula. I would like you to think about the formula, develop the formula, and then give some of these practice problems a good try.